Welcome to this lecture on data analysis, a critical component of risk management, especially when it comes to identifying risks in a project. Data analysis involves examining, cleaning, transforming, and modeling data to extract useful information for decision making. When identifying risks, data analysis helps project managers understand the probability and impact of potential risks, prioritize them, and develop appropriate risk response strategies. In this lecture, we'll explore what data analysis is, its relevance in risk identification, and why it's significant in the risk management process. Let's get started. Data analysis refers to the process of systematically examining data to uncover patterns, trends, correlations, or insights. It involves a variety of techniques and tools that help transform raw data into meaningful information. In the context of risk management, data analysis helps project managers understand the nature of risks, assess their potential impact, and make informed decisions about how to manage them. Data analysis can be qualitative or quantitative, depending on the type of data and the desired outcomes. Qualitative data analysis involves analyzing non-numeric data, such as text, interviews, or observations. Techniques include categorization, thematic analysis, and content analysis. Quantitative data analysis involves analyzing numeric data using statistical or mathematical methods. Techniques include descriptive statistics, probability calculations, and statistical modeling. Data analysis plays a crucial role in risk identification. Here's why it's relevant. Data analysis helps project managers identify patterns and trends that might indicate potential risks. By examining historical data or project metrics, they can uncover risks that might not be immediately obvious. Analyzing data from multiple sources ensures a more thorough risk identification process. This reduces the likelihood of overlooking critical risks and helps project managers gain a comprehensive view of the risk landscape. Data analysis provides the information needed to make informed decisions about risk prioritization and response strategies. This data-driven approach leads to more effective risk management. By analyzing data early in the project managers can identify risks before they become significant issues. This proactive approach allows for timely risk response planning. Data analysis provides the evidence needed to communicate risk-related information to stakeholders. It helps project managers justify risk assessments and response strategies. Data analysis is significant in risk management because it contributes to the effectiveness of the entire risk management process. Here's why it's significant. Data analysis helps project managers identify and assess risks based on probability and impact. By analyzing data, they can determine which risks are most likely to occur and which would have the greatest impact on project objectives. Data analysis allows project managers to prioritize risks based on their severity and likelihood. This helps them focus on the most critical risks and allocate resources accordingly. Data analysis informs the development of risk response strategies. By analyzing risk data, project managers can determine the best approach to mitigate, avoid, transfer, or accept risks. Data analysis supports continuous risk monitoring throughout the project lifecycle. By analyzing risk-related data regularly, project managers can track changes in risk probability and impact, allowing them to adjust response plans as needed. Effective data analysis contributes to improved project outcomes by enabling proactive risk management. By identifying and addressing risks early, project managers can reduce the likelihood of project delays, cost overruns, or other negative impacts. Project managers use a variety of data analysis techniques to identify and manage risks. Let's explore some common techniques used in risk management. Qualitative risk analysis involves assessing risks based on their probability and impact in a non-numeric way. Techniques include ranking, scoring, and categorization. This approach is useful for quickly assessing and prioritizing risks. Quantitative risk analysis uses statistical or mathematical methods to evaluate risk probability and impact. Techniques include Monte Carlo simulations, decision trees, and expected monetary value or EMV. This approach provides a more precise assessment of risk and supports data-driven decision-making. Descriptive statistics involve summarizing data to understand its basic characteristics. Techniques include calculating measures like mean, median, mode, variance, and standard deviation. This approach helps project managers understand trends and patterns in risk-related data. Probability calculations involve determining the likelihood of a risk event occurring. Techniques include using probability distributions, Bayesian analysis, or historical data to estimate risk probabilities. This approach supports risk assessment and response planning. Sensitivity analysis involves examining how changes in key variables affect project outcomes. This technique helps project managers understand which factors are most sensitive to risk and where to focus risk response efforts. Root cause analysis involves exploring the underlying causes of risks. This technique is valuable for identifying the root causes of risks and developing targeted risk response strategies. Regression analysis involves examining the relationship between variables to identify trends or correlations. This technique is useful for understanding how different factors contribute to risk and for making predictions about future risk events. Data analysis is a fundamental component of risk management, especially when it comes to identifying risks. It provides project managers with the information they need to make informed decisions, prioritize risks, and develop effective risk response strategies. By using a variety of data analysis techniques, project managers can ensure comprehensive risk identification and proactive risk management. In this lecture, we've explored what data analysis is, its relevance in risk identification, and its significance in the risk management process. I hope this discussion has provided valuable insights into this essential aspect of project risk management. If you have any questions or need further information, please feel free to reach out. Thank you for joining me, and I wish you success in analyzing data and managing risks effectively.